Here I am going to give you a very good clarity on phasor diagram and oscillations. There are two types of oscillation. One is traveling from the mean position like this to the extreme and then to the mean and then extreme and back to mean. So in this case we represent as x is equal to a sine omega t. There is no phi naught. Why? Because there is the initial starting point t is equal to 0. It is from the mean position only. There is no initial phase. Okay, supposing the body was traveling from here instead of here at time t is equal to 0, then there is an initial phase. That is what is called as initial phase phi naught. Okay, so then imagine at time t is equal to 0, sine 0 0, x is becoming 0. It makes a sense for us to substitute from mean position as x is equal to a sin omega t. The sine graph is also like this, passing through the origin. So x versus t graph from time t is equal to 0, x is equal to 0. It makes sense. When traveling from the extreme position, you should write x is equal to a cos omega t. Imagine t is 0, cos 0 is 1, x is equal to a. You still have the maximum amplitude from the mean position. So therefore, it's appropriate to, when it starts from the extreme position, we'll use this formula. We can also start omega t plus phi naught if there is an initial phase. In this, there is no initial phase because when time t is equal to 0, x is equal to a, which is exactly where we are starting. Okay, so now let's take this pendulum which is operating from the mean oscillating from the mean position. This is a movement which is happening towards the right. This is a movement which is happening towards the left to the mean position. In the phasor diagram, this is 1 and this is 2 because x is positive in both these cases. Please. I messed up this in the class and I want you to become very, very clear. This 1, which is this oscillation, is represented from the mean position. This is the mean position. The mean position projected here. This is the starting point. It's moved here. So this is my 1, which is to this right side. Then coming back is represented like this. So let me do it in different pen. 2 is here. The 3 is negative. The 3 and 4 are both negative. Let me do the third one in a purple color. That has to be represented here. And the fourth one in black color, it can be here because the fourth one is approaching the mean position. This is also coming back to the mean position. This is the starting point. It makes sense. So fourth one is here. This sign convention, you be very clear. So now if I teach you the sum that I taught you in the class where it was a neat question where the starting point is minus root 3 by 2a, which means this is minus a, this is plus a, this is origin, the minus root 3 by 2a is somewhere here and the particle is going towards the negative amplitude. So then in the phasor diagram I told you, you have to represent it like this. Yeah, and this is at t is equal to 0. This is this distance is minus root 3 by 2a is this adjacent side is covering. Let's the phasor, the initial phase is this phi naught. The starting point to the time t is equal to 0. It's unfortunately it's here, right? So phi naught itself is a 270 minus theta. This theta. Why 270 and 90 and 90 and 90 minus theta will give you phi naught. At 270 is a 3 pi by 2 minus theta. To find the theta, use cos theta is equal to root 3 by 2a by a. Where will cos theta be root 3 by 2? 60 degree, which is pi by cos theta root 3 by 2, 30 degree, which is pi by 6. So 3 pi by 2 minus pi by 6, LCM is 6 into 3 is 9 pi minus pi is 8 pi by 6, which is 5 pi by 8 pi by 6, which is 4 pi by 3. So then therefore I got my phase, my initial phase phi naught, and I can write x is equal to a sine omega t plus phi naught, which is a sine omega t plus 4 pi by 3. Because I will put this as x only, x is equal to a sine omega t is when t is equal to 0, x becomes 0. Y is not becoming 0 for this point. Okay, so this graph is about x is equal to. Okay, so clear. So next thing is they are explaining, they are asking you for the time it takes for it to go from the initial position. This is the initial position to the negative extreme. This angle we just calculated as pi by 6. and theta is equal to omega into t. T is equal to theta by omega. Theta is pi by 6. Omega is 2 pi by capital T. Pi and pi get cancelled. T by 12. Part C, there's another question where they're asking, find the time taken for the particle to reach the mean position. So from this instant of time t is equal to 0 to reach the mean position, it's traveling a pi by 6 plus a pi by 2. If you know theta, you can find the time. Theta is equal to omega into t. T is equal to theta by omega. What is theta? Is the whole angle pi by 6 plus pi by 2, and this is 6 and this is 3 pi. So it's 4 pi by 6 or 2 pi by 3. So substitute here 2 pi by 3 into 2 pi by capital T. So the time period is t by, the time taken for it to travel this distance is capital T by 3. So that's the way you answer. You understood the phasor diagram. I'll do some more sums for you to get that absolute clarity with the phasor diagram. Okay. There's one more JE question which I'll do. Okay, before which I'll just teach you this sum. There's this question, x is equal to a sine omega t plus pi by 6. Okay, there's another wave which is like this. They're asking you to find the phase difference. See, the thing is, you cannot compare a sine graph with a cos graph. Therefore, you should convert this into a sine, where when you convert, you should write sine 90 plus omega t. Never write 90 minus. Why? Because in second quadrant, a 90 plus theta, sine 90 plus theta only will be cos theta. Also in physics, in oscillations, sine is always ahead of cos by 90 degrees. Sine is always ahead of cos by 90 degrees. So now you got both of this. You know this is your phase 1, which is omega t plus pi by 6. This is your phase 2 for the second one, pi by t plus omega t. And the phase difference delta phi's magnitude is omega t plus pi by 6 minus omega pi by 2 minus omega t. These two get cancelled, subtracting these two. Pi by 6 minus pi by 2's whole magnitude is 3 pi. So it's pi minus 3 pi, which is minus 2 pi by 6 or a pi by 3. You can write pi by 3 to be the answer. Okay, so always remember to compare, you have to get both as sine, convert cos into sine by writing it as sine 90 plus. So let's go to next question, which is a JE question. A sine omega t minus alpha, y is equal to a cos omega t minus alpha. I will convert this. Y is equal to a sine 90 plus omega t minus alpha. I got this phase and this phase, and I can subtract it. I can get the delta phi, omega t minus alpha minus pi by 2 minus omega t plus alpha omega t. It's minus pi by 2. It's the magnitude. The phase difference they are asking is a delta phi, which is just the magnitude of it, which is pi by 2 in the second case. So I hope you understood. Whenever you convert a cos theta into a sin theta, you can write it as sin 90 plus theta. But whenever you convert a sin theta into cos theta, you should write cos 90 minus theta. I hope you are very, very clear with this, without which we cannot proceed again. So then let's go to next. The next thing that I taught you here in this, and I'm going to teach you is about the JE question. 1 second, let me take that question. Where was the question? 1 second. So I'll recall the question and do the sum on my own. Okay, I think there was a question in which the block was here. This is the origin. The block was moving towards the right, and this distance is 0.5 a. You know, this is plus a and this is minus a. So I'll immediately compare this with the phasor diagram, which is here. At a time t is equal to 0, this is where it is. This will be the phase difference, which is phi naught. The question is about finding the phase difference, initial phase. You know that you want this phi naught. That's the question. And this adjacent is 0.5 amps. You make sure that you're projecting it like this on the, and you get this angle, and this is a, and you get this cos theta. What is cos theta? Is 0.5 a by a and a get cancelled. Cos theta is equal to 1 by 2. When will cos theta be 1 by 2? You know, cos theta is 1 by 2 at 60 degrees. So this angle is 60 degree. Therefore, this angle will be automatically 30 degree. So you get pi by 6 to be the phase difference for this. Initial phase is pi by 6. Sorry, phase difference. No, initial phase is pi by 6. Therefore, if you want to express this, you can write as x is equal to a sine omega t plus pi by 6. This is the way we represent this as a simple harmonic motion expression. Supposing the question is different. Supposing they ask you the time taken for it to move from this point to this point. This is the time that they're going to ask you. You know that this angle is 60 degree. And the time taken for this is what they're asking. You know, theta is equal to omega into t is equal to theta by omega. Theta itself is 60 degree, which is pi by 3. Omega itself is 2 pi by capital T. Pi and pi get cancelled, t by 6. Therefore, the time taken for this journey is t by 6, small t. The small t is the total time period by 6. Okay, so something like that. We can ask you different questions like that. See, another sum, I'll just tell you. The block is here. It's trying to move this direction. Again, it's 0.5 A is position at a time t is equal to 0. Minus 0.5 is position moving towards A. Minus A. So again, you know that I will represent this as a phasor diagram like this. And this is where my point will be. This is where is minus 0.5 A. And this is my A. And I will find cos theta. And my initial phase is from the starting point. Oh my god, this is phi naught, which means this bob is gone from here, then come back here. You understand this whole angle this is phi naught, which is what I'm trying to find. And from this diagram, you know phi naught itself is 270 minus theta. 3 pi by 2 minus theta. To find theta, you can do cos theta is equal to 0.5 A by A. So cos theta is equal to 1 by 2 and theta, where it will be 1 by 2. You know that cos 60, so it's pi by 3 in this case. In that, then the 3 by 2 minus pi by 3 is what you have to do in order to get the phasor, and the LCM will be 6 and you do into 3 and into 2. Into 2, this will be 9 pi and that will be 2 pi and it will be 7 pi by 6. So let's see what I'm doing is right. So I'm trying to find the initial phase. That's the question. So if you're going to find, they ask you the question to find the initial phase for this instant when the particle is here, then this is the way you do. You want to find phi naught, and cos theta is equal to 1 by 2, where 1 by 2 comes only in pi by 3. So then therefore you substitute here, you get some. This is your initial phase. Suppose you want to write it, x is equal to a sine omega t plus 7 pi by 6. Yeah, that's your phase. But instead of, this is what it is. Okay, there's one more question where, I'll do this, which will give you absolute clarity now. This block is going to come towards the main position, same 0.5 meters. Then that graph has to be drawn in like this. The phase angle is, this whole angle is phi. Therefore, instead I will write minus phi. This angle is better. I'll write it as minus phi. Instead of this phi, I can also write minus phi. So basically, I want to find this. I know this is at a distance. Can you see this is at a distance 0.5 A and this is A, and you can find this theta using cos theta is equal to 0.5 A by A. Again, you get theta to be pi by 1 by 2 cos 60 pi by 3. So you know this is pi by 3. This will be pi by 6 and it's minus pi by 6. So the phase difference is minus pi by 6. So in this, if you want to represent this, is A sine omega t minus pi by 6. I hope you're clear. I hope you're clear. So this questions that I discussed here would have given you an absolute clarity as to how to approach sums in case of phasor diagrams. Okay.